Hello everybody, I've got the assignment 4 opened up in an older version of Unity here. So I've got it opened up in the 2022 version of Unity. I believe it will open up in the 2021 version of Unity, but I haven't actually checked. When you import the project into Unity, Unity should install all of the required packages. One of the packages I'm using is a third-party package called Parallel Sync. I'm hoping that Unity will import it correctly, so it's part of the project. I'm hoping it installs correctly if you're on a different platform. If it doesn't, go to the Parallel Sync GitHub. There's a link on the assignment. Go to the releases section and download the 1.52 release of the Unity package. And then you can go to your downloads, drag that into your assets folder, and that should install Parallel Sync into your version of Unity. Hopefully you don't have to do that. So we're using Parallel Sync to simulate multiple computers on a single computer. All right, so once you've got everything imported, you're going to want to go to Scenes and open up the sample scene. And you should see something that looks like this. You'll want to click under the Parallel Sync menu and open up the Clones Manager. So you should see there are no project clones found, so create a new one. So the way Parallel Sync works is it basically clones the Unity project into a new project. So you see here it's going to copy this project into another project. And then it's going to link the two projects so that when you make changes to one, to the original, I guess, things change in the clone. I don't think the process always works perfectly well, so sometimes you have to reload the cloned project. You're going to want to open that in a new editor, and so of course this is going to be a little bit slow because Unity takes a long time to open up a new project for the first time. Okay, so after a few minutes, you should see the cloned project open up. In the assignment, there's a few of these objects that we're interested in. One of them is the network manager, sorry. So the network manager, that is the one object, the singleton object, that's responsible for the networking, for maintaining information about the networking. So under in the inspector, under network manager, one of the values that we're interested in is the tick rate. And so this is the rate at which Unity updates changes over the network. So when you open up the project, it should be set to 1, which means Unity will be sending information over the network once per second. Later on, we can change that and see what its effect is, but it should be set to 1 when you start up. Under prefabs is where you'll find the pink purple player. So it's the network object that corresponds to the pink player. So the pink player is the player that the local player is always under control of, and I'll show you what I mean by that shortly. If you go to the network object component of the player, you'll see that synchronized transform is ticked, and so that means that the player object has a network transform. So whenever the local player controls the position of the pink character, or I guess of the pink avatar, the position of the pink avatar is being updated over the network via its network transform once at the network tick rate. The transform itself is defined as another component, and you can see here that we're sending the X and Y position of the player each time. We're not sending the Z component because this is a 2D game, so the Z component doesn't matter. We're sending the rotation about the Z axis Again, because the rotation about X and Y don't matter in a 2D game. And we're not sending any information about the scale. The thresholds are set to 0 and the rotation angle set to the smallest value possible. So by setting these to 0, this forces Unity to always send the information about the transform of the object, even if it doesn't change. So if you set these to a non-zero value, so for example, if you set this to 1, then Unity will only send information about the transform if the position, one of the position components changes by more than 1. Right? If it doesn't change by more than 1, then the transform isn't sent. That will cause some funny behaviors when we use dead reckoning, and I'll show you that later on. The other, and perhaps the most important thing that we want to look at is the player controller script. And so the player controller script, this is the file that you'll be editing for the purposes of the assignment. So in the well, let me run the assignment first, and then, or run the completed assignment first, and I'll explain what's going on. Okay, so if you make changes to the tick rate or any of these, any of the values over here, you always need to save the scene. Otherwise, the other client, otherwise the other project doesn't get the changes. And that's going to cause the other, the cloned project, you won't be able to, it probably won't behave properly. Okay, so once we've saved the scene, I'm going to press play in both projects. On one, you're going to start as host, and you can see that creates the pink character or the pink avatar, which you're under control of. And so the person that's controlling the pink player, I'm calling that the local player. Right? You can see over here that the network object corresponding to the player, I've changed its name in code. So you can see that this is the player on the host machine. A host machine is also a server and a client, so it also says server client, and it's the local player. Come back, right? So here we go, right? So that that pink player is the local player on the host machine. So if you click off somewhere, the mouse input no longer goes to the I guess to this machine over here. And so the pink player, the pink character just oscillates back and forth. Over on the other project, I'm going to launch as client, right? And so when you launch as client, you'll see a blue player appear. The blue player is the player from the other machine. And so on the cloned project, I'm controlling the position of the pink character. And if you look over on the right-hand side, in the original project, you can see the blue player following the pink player on the left-hand side. And so here we're using teleportation. So every time there's a network update, we update the position of the blue player by teleporting it to its new position. Right. Okay, so I'm going to stop that. Stop that. So in the script, you are most interested in the fields used by the remote player controller. So remember that when you launch two clients, one of the player objects in the scene corresponds to the remote player object. I guess I should explain that a little bit more carefully. So let's do that again. Okay, so I'm going to launch the host over here. I'm going to launch the client over here. All right, notice over here there are 3 players. Right, so there is the local player. So that's the one controlling the pink object over here. There is the remote player as well. So the remote player is the Unity created object that corresponds to the pink player over here, right? And so over in this view, there is a object that's not being rendered that corresponds to the remote player, so the pink player over here. So all of the network transforms that this pink player is sending is going to that remote player object right there. Now we're not rendering that remote player object. Instead, we're rendering the other player. So the other player is the blue character in the screen. So we're using the information being sent to this object to control the position of this object here. And so that's what's going on. So in your player controller script, the script is being written from the point of view of two different observers, right? One is for the local player, and the other one is for the remote player. So the fields used to control the position of the blue character on the screen, those are the ones, these are under the section labeled remote player controller. If you're interested in the local player controller, these are the fields that are used to control the pink character on the screen. Okay, so the way that we move the remote player is controlled by this string here. So we're either teleporting the remote player, or we're going to use a smooth correction of the remote player. So if we change this to mode correct, instead of teleporting the blue character to its most recently updated, to its most recent position as updated over the network, we're going to move in a straight line to the new position. So that's called a smooth correction. So if we do that and let Unity recompile and run both projects. There we go. Start this one as a client. Okay, so I'm controlling the pink player on the machine on the left. So on the right, you can see the blue player is, instead of jumping from position to position, it's moving in a straight line from position to position. So here we're updating the network only once per second. And so the blue player is lagging the pink player by roughly 1 second. Okay, I'm going to set this back to teleport. And now I'm going to modify the use dead reckoning field. When we use teleportation, we move the blue character every time we get a new update over the network. In between network updates, the blue character just sits at its previous position. So instead of just sitting at its previous position, we can guess at its position while we're waiting for the next network update. So to guess at its new position, we're going to estimate the velocity of the other player. And then using the estimated velocity, we can update the position of the blue player between network updates. So when we set that to true, that's the process that we're going to use to update the position of the blue player. To estimate the velocity of the remote player, you need the time between network updates. So previous network update time is the time at which the last update occurred. The current network update time is the time at which the most recent update occurred. So the difference between these two times is the time between the last two network updates. This field update consumed is set to false when a new network update arrives. Once we've processed the most recent network update, we're going to set that to true to indicate that we've used the most recent network update. The other piece of information that you need to estimate the velocity of the remote player is its current position as updated over the network, and the position at the previous time step. So that would be the remote player current position and the remote player's previous position. We also keep track of the directions, so the direction that the player is facing in. So the remote player current direction is just the up direction or the direction of the y-axis of the remote player at the most recent network update. And that is the direction of the remote player's y-axis at the previous network update. Okay, so we've got teleportation on, we've got dead reckoning on. Let's see what happens. Let's save that, recompile both projects. Okay, so over here, I'm going to start the client. All right, so we're using teleportation, but we're also guessing at where the player, we're also guessing the velocity of the player between network updates. So you can see on the right-hand side, right, the blue player teleports to the new position each time, but it continues moving in a straight line in the direction that it thinks the purple player was moving in. Right. So if we're moving in a straight line on the left-hand side, dead reckoning produces reasonably good results, right? But every time we make a turn or change direction, obviously dead reckoning ends up sending the blue player off in a funny direction, and then we have to do a fairly large teleportation to correct the position of the blue player at the next network update. Okay, so we don't have to use teleportation. We can also use, instead we can use correction. So if we switch this to mode correct and leave dead reckoning on, the results are slightly better. There's no jarring jumps, so there's no stop and go motion caused by the teleportation. But the use of dead reckoning over a period of 1 second doesn't really produce great results. So again, watch the blue player on the other screen, right? And so the blue player doesn't jump from position to position, right? And in between network updates, it's guessing at the direction that the pink player is moving in. It doesn't do a bad job. Actually, it does a reasonably good job, given that the network updates are so infrequent. But it still doesn't perfectly replicate the motion of the pink player. Again, I mean, we're only updating the position once per second, so it's not surprising. Also notice that every once in a while, the oscillation bugs out. So you just have to click in the other screen and set the other player moving again. Okay, so let's see what happens if we change in the network manager, if we under prefabs, if we change the player's network transform. So if we change the position threshold to some non-zero value, so let's say 0.01. Now Unity will not send an update. So Unity will only send an update of the transform if the position changes, if one of the components of the position changes by more than 0.01 units. So if the player is perfectly still, Unity won't send the network update. And so that means instead of sending the network update once per second, it could be a very long time between network updates. So if you use dead reckoning, and it doesn't matter whether you're teleporting or correcting, you're going to get funny results. So let's see what happens when we do that. So if you change something over here, don't forget to save the scene. Otherwise, the other clone won't get the change. Okay, so start the host over here, start the client over here. All right, so I'm going to move the pink player around for a little bit, and then I'm going to stop. Right. So notice what has happened over on the right-hand side. Let's try that again. So I'm going to move back. Okay, so I'm going to move around a bit. I'm going to let the other player catch up, and then I'm going to stop. So notice that because we're using dead reckoning and we're not receiving any network updates, the blue player just continues moving in the direction that it was moving in the previous step. Right. So once again, right? It's not getting any network updates, so it thinks that the pink player has continued moving in a straight line, and so it just keeps on going off the screen until we give it a network update, and then it comes flying back in. Right? Okay, so I've set these thresholds to 0 so that you don't have to, or that you don't, you're not affected by that when you're using Dead Reckoning. Right, so I'm forcing the network updates to always happen. All right, so I guess we should go back and look at the source code very quickly. And so you're mostly interested in the code that deals with the remote player. Right? Most of the code's written for you. So in the update method, so you're familiar with this from a regular mono behavior, right? Update's called every frame update, so 30 times per second by default. If we're updating the position of the remote player, we're going to call update remote. So down here, if we're updating the position of the local player, we're calling update local. So this is where it reads the mouse input up here. So that's how you control the position of the pink player. Update remote is right here. So in update remote, this is where we're updating the position of the blue character. Right. So if we've used the previous or the most recent network update and Dead Reckoning is turned on, we're going to guess at the position of the blue character of the remote player using Dead Reckoning. So you have to write this Dead Reckoning remote player method. If we've got a new network, if one of these is false, so if the if the most recent update network update has not been consumed yet, we're going to teleport to the new network position. Otherwise, we're going to, if we're not teleporting, we're going to move smoothly towards the next, towards the most recently updated network position. And so you need to implement these 3 methods. So I recommend you implement them in the order teleport, then correct, then Dead Reckoning. So the assignment has pretty detailed instructions on how to implement these. All told, there's probably somewhere between 15 and 20 lines of code that you need to write. If you implement this one first and switch the mode to teleport and switch Dead Reckoning to false, you can test to see if teleportation is working correctly. Once you've got that working, you can implement correct remote player, switch the mode to mode correct, right? Make sure Dead Reckoning is false, right? Run the game, see if smooth correction does what you think it does what you want it to do, and then finally go ahead and implement the Dead Reckoning method. Turn this on to true. Maybe fiddle turn this to teleport to make sure it works the way you expect, and see if Dead Reckoning also does what you want it, what it should be doing. All right, so I don't think there's not much code to write. Now, if you're having trouble getting Unity set up, so if you're having trouble getting Parallel Sync to work, or if you're having trouble just getting things to work in general, drop by during office hours next week. I'd be happy to help you out. I guess you can try sending email, but I'm pretty behind on my email, so it might take me some time to get back to you. If you send me an email. It's also much harder to debug by email. So if you're really having problems, it's probably in your best interest to drop by during office hours or try to schedule a meeting with me. All right, that's all I have for you. Good luck completing the last assignment.